Hello, this is Number Systems Part 5, Converting Between Binary and Decimal and vice versa. Decimal numbers are the ones that we're most used to. They're based on the number 10. So you have the ones place, the tens place, the hundreds place, the thousands place. Each one is a power of 10 higher. Binary, based on the number 2. If the ones place, then the twos place, then the fours place, then the eights place, then the sixteenths place, and so on, each one a power of 2 higher. Each of those numbers with that base, because there's only that many options for single digit symbols. Decimal with 0 through 9, and binary with only 0 and 1. Computing is done almost exclusively in binary, and our everyday math is done almost exclusively in decimal. So we often need to go back and forth. So I'm going to talk about that in this lesson, in this video. So let's start with a binary number, 1101. If you wrote down that number 1101 on paper, someone would look at that and probably say, hey, that's the number 1101. But we want it to be in binary. So what we would do is we would put a little subscript 2 at the end of that number. So it would look like 1101 subscript 2. Then you would know it's not a 1 in the thousands place, a 1 in the hundreds place, and a 1 in the ones place. Instead, that first one on the right is a 1 in the ones place, a 0 in the twos place, a 1 in the fours place, and a 1 in the eights place. So that's 8 plus 4, not plus 2, plus 1. 8 plus 4 is 12, plus 1 more is 13. So 1101 is the number 13 in decimal. You look at each place value, the ones, the twos, the fours, the eights, the sixteens, and so on. And if there's a 1 there, you add that number in. If there's not a 1 there, you don't. And that gives you the total you want in decimal. Going from decimal to binary is a little trickier. It requires a little bit of subtraction here and there, but it works similarly. Let's say we had the number 11. Now, if you wrote down the number 11, now that we've been talking about binary, you might think, oh man, is that 11 or is that the binary number 11, which would just be the decimal number 3? We can put a subscript 10 at the end of the number to indicate that it's a decimal number. So you'd write 11 subscript 10 to tell you that's actually the number 11. So how do we do this? Well, we look at our places in binary. You have the ones place, the twos place, the fours place, the eights place, the sixteenths place. Oh, we don't need the 16th place. If we put a 1 in the 16th place, we'd already have 16. That's more than 11, and we're already done. So the highest we need to go is the 8th place. Now, 8 can fit inside of 11. I forgot we were doing 11. 8 can fit inside of 11, so you do put a 1 in the 8th place. Now, the 4's place is the next place. Do you put a 1 in the 4's place? No, we can't, because 8 plus 4 would give us 12. So we know we have a 1 in the 8th place, a 0 in the 4's place. Let's look at the 2's place. We have 8 plus 2 more. That would give us 10. We do want a 2, and we need a 1 in the 1's place to give us that 11. So where does the subtraction come in? After we put that 1 in that 8's place, you could have done 8 minus 11 and seen, oh, we need 3 more. Can't use 4, have to use 2. 3 minus 2 leaves us 1 more, have to use 1. So we have a 1 in the 1's place, a 1 in the 2's place, a 0 in the 4's place, and a 1 in the 8's place. So 1011 subscript 2 represents the number 11 subscript 10. That's how you can go back and forth between binary and decimal. And there's lots of algorithms that computer systems use to do it, but we can also do it in our minds or on paper. Thanks.